Hello, and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronics supply chain fields. I'm Mike Buetow, president of PCEA. When I first entered this industry, back in 1991, one of the first articles I wrote was on the state of the ECAD industry. Back then, the big three players were Intergraph Dasix, Mentor, and Cadence Valid. But more than 35% of the market was held by other vendors. CAD tools were fairly primitive by today's standards. Cooper and Cheyenne had just introduced the first shape-based router the year before. Only a couple of vendors' tools offered copper pouring. That was Raycal Redac, which is now Zuken, and Omation. You remember them? And no design tools took data in from the fabricator. Even then, however, designers were pushing back against the notion that the CAD tool did all the work and they were just button pushers. Over his 3 decades in electronics design, our guest today has had ample experience overcoming that button pusher pejorative. Still, he'd probably be the first to tell you automation in printed circuit design is both underappreciated and underused. Stephen Chavez has spent the past 12 years as a principal engineer and global subject matter expert of PCB design for Collins Aerospace and Raytheon. This year, he joined Siemens as a senior product marketing manager, where he focuses on methodologies for adopting a strategy for resilience and integrating the design-to-source intelligence insights from Supplyframe. And I should disclose, he is also chairman of the Printed Circuit Engineering Association, which makes him my boss. Steph, welcome to PCB Chat.
Thank you. It's my pleasure to be here, and I'm very excited to have a discussion with you on the topic of automation and harnessing the horsepower in today's EDA tools. So I'm very excited about this.
Well, we're going to come back to that in a second. So automation takes many forms, and we couldn't possibly cover all of them today. But let's start with auto routing. Many veteran designers tell me that they prefer hand routing to relying on the tool. Why is that, and where do you fall in that camp?
So first, I would tell you when they say hand routing or manual routing, what they're really describing is interactive routing, where they're manually control it, but it's adhering to rules that they have in place. So they call it interactive routing. That's the more a better term to use, because when I think of someone who says I'm routing without any addition or any rules, it's basically you're just hand routing freely, and then you're checking for rules after the fact, which many people will say, well, you're turning your DRC off and routing a trace, then you're turning it on and then checking. Well, what if you just leave it on and let the rules guide you as you're flowing that trace from A to B? And that's the interactiveness of automation in the tool, but yet you're still controlling it in that way. So that's the description of what the majority of people are doing today is interactive routing.
Okay, fair enough. So would you, in the many years when you were actually designing boards, how would you approach it?
So I too, for the longest time, was very adamant that I would not auto route. And it wasn't until I'd say about a decade ago on a specific project that I took a chance and I tried to see if I could cut out some time in the design cycle because of a particular engineer's efforts to try to get home for the holidays. And I thought, I always hear about the automation in the tools, but yet I never do it. And I was, because of, legacy of this is the way I do it, or this is the way I was trained to do it by a lot of my mentors who are amazing. That was my mentality. And so I gave it a shot, and I was stunned on how fast I can not only finish the design, but how fast I was able to adapt to changes that would come at me, and I could recover very quickly. At that point is when my whole mindset changed. It was like I had my aha moment in my career. And then I asked the question, why doesn't everyone do this? And it's all about, what do you feel comfortable with? And what do you think it's going to take to be successful? And everyone, for the most part, they have their comfort zone of where they're with their tool using the same 20 clicks that they do on average, and they stick within that comfort zone because that's what they know what it takes to be successful. So harnessing that horsepower in the auto router, you have to, it's like riding a bike for the first time. You're going to fall, you're going to stumble, but you got to get back up on it and use it to your advantage. And that's my take of why we still have the essence of, you go today, like at PCB West, and you ask, how many of you auto route? Almost 90% of the people will say they don't. So it's not that, that's the best practice. It's just, that's what they know what it takes for them to be successful. And there's nothing wrong with it. It's just, if you have a tool that you've paid for that has that automation and horsepower, why aren't you taking advantage of it? And the way I see it is that you could be faster and you could be better if you harness that horsepower. And when I think of, being able to eliminate or shorten your design cycle time, I look at work-life balance. It takes you interactively, let's say it takes you 10 hours to do that section of the design today. But what if you can cut it down and do it in 6? You've just saved yourself 4 hours. 4 hours that you can get home to your family, little league, choir. Let's be real. Today, we, as parents, we have a lot of external activities, and work-life balance is key. And if you can utilize this horsepower to bring the best return on investment for your company, as well as to bring balance in your life, why not do that? And if you're in competition, I'll say real quick, if you're in competition as a service bureau, being able to design faster is key, with higher quality and being able to do it faster than your competitor. Because I guarantee you, if you're not doing it, your competitor is.
Is it as simple as just the lack of familiarity with the auto router and maybe some concern over whether to trust the results that is inhibiting design engineers from going that route? No pun intended.
No, I think you're right. I think a lot of it has to do with control. They don't feel like they're in control, and in reality, they are. They control every step. Um, if you are putting constraints into your design, you're basically structuring to take advantage of auto router, but you're just not actually utilizing. When I say auto router, is controlling how you tell the system, okay, I want you to make these connections. You can control every aspect of it. Some tools are stronger than other tools in that regard, but nonetheless, whatever tool you are in, my advice is to look to see where you can be better and faster. It will play to your advantage, especially when it comes to adapting to change. And let's be real, in PCB design, that's one thing that's constant for us, is that you get last minute changes. But what if you got to move a connector that's got a lot of tuning to it, or a BGA that's got tuning that, whatever, ICs that are connected to it have to be moved because either addition of circuitry, or maybe, God forbid, there's a mechanical hole that didn't get brought over from MCAD. So guess what? Now you got to shift things. If you have to do all that manually, that could be several days to a week of hit in your design. If you utilize automation, it's a matter of maybe a half hour to an hour of the hit. It just depends on the complexity of the circuit you're attacking.
How relevant is the type of design in that decision-making process, as to whether to use the auto router? I mean,
It plays a big difference.
Examples, right? But what if somebody's just designing sort of a simpler circuit, a 2 or 4 layer board, maybe no controlled impedance or anything like that?
Yeah, I would tell you. So the more complex your board is, the more your thoughtfulness in how you apply the auto router makes a difference. And you can't just push the button. Literally, you can, but you're going to end up with a plate of spaghetti that will not work when it comes to EMI. It'll be a disaster. I mean, Rick Hartley can tell you, decades of experience of, what he has had to go and fix because people just don't understand the concept of board design. And so our tools are capable of doing that, but you have to control what you're doing. And it's just like interactive routing, but you're now harnessing the power of the tool to do it for you.
So it's less about what the auto router itself can do and more about what the designer, what kind of constraints they put in to ensure that the auto router does the job the way it's supposed to for that particular design.
That's correct. And I would tell you, you can't auto route every design. You have to take a look at the design that's being proposed to you, and then look to see where you can. A lot of RF designs cannot be auto routed because you have a lot of shapes, and the complexity is very difficult. But that's not to say you can't utilize automation in another way of how you bring in the shapes, and how you're utilizing your tool. There's other means of automation to it, but what we're talking about specifically on auto router, it just depends on the complexity of your tool, of the design you're up against, because your requirements come in at the very beginning stage of your design cycle. Then you apply those requirements to create your rule set, whether electrical or physical, of how you're now going to constrain your design to get you from A to B. The bottom line is it comes down to control. The designer doesn't feel like he's got control, and he feels like he's creating this, a mess. You control that. You created a mess. Yeah, it created a mess because you didn't control it. You can start the auto router, and as it starts to route, you can pause it at different stages. You can say, on this first pass, I only want you to route on layers A and B. I want you to route on this next pass C and D. You can choose. I only want you to route these constraint classes. You can control so much, but there's a hesitation to it, and a lot of it is you do got to take the time to learn the tool. Most legacy designers have been doing it for 30 years. They stick to what they know. They stick to the success formula that they have. That's fine, but as our designs get more and more complex, you've got to find a way to use the auto router. You're not utilizing all the horsepower that's there. There's just so much that we can be doing better and faster. And some people get it, and some people they kill it, but they're not bragging about it. Why? Because their customers are going back to them and they're killing it, and they don't need to they don't need to showcase, hey, this is what I'm doing. They sit in the class, people like, I'm not auto routing. They just kind of nod their head and like, oh yeah. In their head, they're like, if you and I are quoting on the design, I'm going to beat you. And I can charge more money. The problem you have to be mindful of is you don't want to over constrain your design to where then you can't route anything, even if you try to do it interactively. It just won't work. And so there's a fine balance that you have to have, and sometimes you got to make trade-offs.
And you're probably encountering that a lot in your new role where you're taking information from Supplyframe and helping people understand how to use that information. And we're getting into this. We've been in now 2 years deep into this situation where parts are just hard to come by, and what what you're designing to on day one may be very different on day 7, day 14, day 21, just depending on what parts are available on that particular day. And so there's, I would say, an increase in the number of respins just based on parts availability. Does that all sort of jibe with what you've been seeing?
Yeah, absolutely. So I would tell you, in the last 2 years that we've experienced the disruption in our supply chain ecosystem, it has directly affected engineering teams, and the direct reflection of the negative impact is that parts are not available. But the problem is that when the design engineer is selecting his components at the point of design, in our current ecosystems that we have, it's not inherent to have that visibility for external touch points regarding the supply chain intelligence of what's available, who has it. The engineer doesn't know that at the point of when he's selecting his components. That's not evaluated until the BOM is evaluated of his schematic, is given to supply chain. Supply chain does an analysis, gives him his feedback. But at this point, the AA is not waiting for that. He is moving on. He's handing that circuit off to the designer, the layout, the designer starting the layout. So you get things happening in parallel. So by the time the feedback does come back to the AA, which could be a day, 3 days, or even a week, he gets information, hey, 20 parts on your BOM are not available. And in Mil-Aero, when a part is not available, it doesn't mean just that part. It means that and all of its alternates are not available. So what do? Do you Do you take the hit on the delivery of your product because you have to wait for parts to come in to be assembled? Or do you try to find an alternative circuitry that you'd have to, reevaluate to see if you're able to implement that in your design, which ripples to redoing that portion of the layout, or you just eliminate that feature that you were going to deliver that was a requirement coming in. And those are the type of dilemmas that have to be asked. And what do you do? And so going forward, we have to arm the engineers to make better, intelligent decisions with the external information from supply chain. So that way, when he's selecting his components, he knows what's available and what isn't available, so he can make intelligent decisions. And that's where we're at this new, I want to say crossroads, but where we need to now, as design engineers, we need that information so we make intelligent decisions going forward, because the old approach isn't going to work going forward. You can't sustain it with all the delays that we're having with supply chain.
So in other words, the design engineer needs to be able to see what the procurement people see, same time, real time.
Exactly. That real time information is knowledge at the point of design. And that's where we need to evolve to. And so our tools that in our approach is to integrate what, the supply chain information into the engineering's hands, or his visibility, so he sees that, so he makes intelligent decisions on the fly. Because the worst thing to do is to wait till after the fact, which I just described. Our normal process, our current process now, it's a legacy process, is that you do BOM analysis downstream, and by the time you figure, or by the time you're notified that you got parts that are not available, you've now got to rip up designs and take a step backwards. And I can attest to that. And I produced a webinar and a white paper and a couple of columns regarding this specific problem, and I gave a testimony of a recent job I was on, and I must have redid that layout 12 times before we ended up finishing. And it was just like one step forward, two steps backwards. Like every other day at our project meeting, weekly project meeting, it was another part was unavailable. Another part became unavailable. And it's what do you do? Well, how do you mitigate that? And the way to do it is to try to get that intelligence up front. And so that way it arms the engineers so they can produce, a product that the parts are available and they're there, so the supply chain can grab them very quickly. Because, like I recently said, one of my posts on LinkedIn is that you can design the best board. You can have the best engineering team design the perfect board, but it is useless if you have no parts to assemble it. What do? You're dead in the water. So getting that knowledge up front, so that way you make intelligent decisions. So when you pull the trigger and send that board to fabrication, your supply chain team has now had acquired the parts in hand, so that way they can assemble your product.
Changing the subject a little here, but as you mentioned earlier, and you often talk about harnessing the horsepower of the EDA tool. In practice, what does that actually mean?
So, when I talk about harnessing horsepower, it starts from the very beginning. Every design starts from a mechanical standpoint, because that's the envelope in which we're going to design from. That gives us our board outline, our mounting holes. So that exchange from MCAD, ECAD, that is the first integration where you're harnessing the horsepower when it comes to intelligent data. Or in the past, what we've always done is, they'd give us a drawing, whether it's a DXF file or a manual PDF, and now we have to manually draw this in our system to start with. Well, when we talk about harnessing horsepower, you can do this automated, and that's the first stage of the automation. Your placement, when you're creating schematics, our tools, if you got to do banks of resistors or however you're placing your components, there's horsepower, and it allows you to do that very quickly, rather than to pull apart one at a time and pull it down and place it in your schematic. That's at the schematic stage. Then you have the integration between MCAD and ECAD. It's tightly integrated within our tool systems that we have today. And it doesn't matter which tool you're using. You have that functionality from your schematic to your layout, and that tightly integrated process. And then when you go into layout, there's so many ways that you can harness that horsepower up front in the schematic by grouping your circuits or putting them in clusters. So that way, when you go to place it, you're not placing one at a time. You can place a cluster. And then, another thing when I talk about harnessing horsepower is if you're using repeated circuits that you've done over and over, why do you continue to do it? Why don't you save it and reuse it and create a reuse module in your library that's already a vetted known circuit, whether it's a power supply or any kind of driver that you would have, then you can just reuse that. And I know that, the pushback will be, well, that might not fit in this form factor, this new form factor I'm in. You know what? But I'd rather start with something and then only have to change 30% of it, because then I'm still that much more ahead. I don't have to redo it. I'm not reinventing the wheel completely. You know what I mean? So there's so many ways to automate and utilize your horsepower when you just doing your constraints. Are your constraints structured correctly? And then why do you create new constraints for every design if you're still targeting the same 8-layer board, you're still targeting the same 100 ohm, 120 ohm, or 50 ohm impedance requirements? Why don't you create a base constraint template and then import it from at each of your design? Create starting templates. That's what I'm talking about, harnessing the horsepower in your tool. So you're not reinventing the wheel every time. There's so much way to do this. I mean, when you generate your outputs, are you manually clicking 10 buttons in order to generate all the required outputs for manufacturing? Or are you simply using intelligent data, whether it's ODV++ or IPC 2581, and you generate this information? But there's just so many ways to utilize, the horsepower. There's integration with signal integrity that you can be doing on the fly. And today's tools they're far superior than yesteryear's tools of days in the past. When I first started, 30 years ago, it's amazing, the capabilities that are there today. And I think designers today, should take advantage of it, especially, our companies are paying, a good penny for these tools, and, you're still using it as tools of the early 90s. And why, when we have, more capability to do what we can do today? When we talk about 3D modeling, and it's just amazing. It's amazing.
I go back to ECAD 30 years ago, and it was very siloed, as you remember. Today, the major vendors are looking at the bigger ecosystem and developing tools that take that design from schematic through assembly. So much in the way that the auto router is underutilized, I kind of wonder whether the same thing is happening down the line, that we aren't taking full advantage of what's available or possible. To that end, how critical is it to the design to fab to assembly flow today that the data be bidirectional and tools take data in as easily as they output it?
It's extremely critical. And I would tell you, when we teach, a CPCD course for PCEA, getting all the stakeholders' information upfront is key. And that includes your external stakeholders, which is fabrication and your assembly house. Getting that information up front is key, because you want to make sure that you have that knowledge going into your design from the very beginning. And the seamless handoffs that you can do with the less potential for any pauses in the design. So, for example, if you generate data that you don't have any manufacturing feedback from the very beginning, and you send that stuff to fabrication, you're more likely to get a technical query, which is a TQ, come back at you, which meant that your job got put on hold because there are inconsistencies or there are concerns in the design that the fabricator needs clarification on. And that's the worst thing, because your job is now on hold, and it could take anywhere from a day to a week before you can rectify the problem. And it's even worse if it turns out that you designed something that is impossible to fabricate, meaning that you were shooting for 120 ohm impedance, you used a specific trace width, you used a specific stack up from your signal to your reference plane and the height, and what you designed doesn't give you 120 ohms. And in order to change it to hit the target that the supplier is recommending, it's physically impossible in your current stack up. You're going to have to change. That's too late in the design cycle or the design process for you to get that, since your design is done. you should have that information up front. It should already been dealt with. So it's critical that you get these inputs, these bidirectional inputs from the very beginning and throughout the entire process.
And you will be talking more about this as part of your class at PCB West this year, right?
That's correct. Yes.
And that course is on Tuesday, October 4th at the Santa Clara Convention Center. So people that want to know more about that can go to pcbwest.com. Now, you mentioned the CPCD course. That's the Certified Printed Circuit Designer curriculum that was developed by several printed circuit experts, including Mike Creedon, Rick Hartley, Susie Webb, and yourself, among others. Do you want to mention the goals of that program?
So the goals of the program is to, educate and arm designers today with a solid foundation to be successful in printed circuit engineering. So that way that you know the correct way to design a printed circuit board for fabrication and assembly. And we talk about the printed circuit engineering triangle, which at one point I was nicknaming the designer's triangle, but it basically it's get it right the first time. Your solvability and your placement and mastering your CAD tool at the same time. That's simultaneously at the same time. Then you have another leg of this triangle, which is your signal integrity and your performance and power integrity. And then you have the third leg of the triangle, which is your manufacturability and producibility. But when we talk about, getting it right the first time, you have to have all three aspects simultaneously. You're challenged to successfully create and produce. And if you follow in the course, and if you apply what we teach and what you learn from it, from decades of lessons learned between the authors that put it together, you will be successful. Your potential for success is drastically increases. And what we teach is of the latest technology today, of years and decades of lessons learned that went into this course. So I'm very biased because I'm one of the authors, but it's an amazing course. If you get a chance, my advice is check it out. You won't be disappointed.
And folks can learn more about that at pce-edu.com. And for the rest of our listeners, PCB West, the leading conference and exhibition for printed circuit and design engineering, takes place October 4th to 7th at the Santa Clara, California Convention Center. And again, the URL for that is pcbwest.com. Steph, I want to thank you for joining us on PCB Chat today.
It's my pleasure, Mike.
Our guest today has been the chairman of the Printed Circuit Engineering Association, Stephen Chavez of Siemens. For PCB Chat, this is Mike Buetow. Have a nice day.